everyone, welcome to Xiaohei Classroom. In this section, we will introduce the application of single-axis motion control in the motion control function of M226CS, and then we communicate with EtherCAT to control it. First, we need to configure EtherCAT communication in the hardware configuration. Double-click the CPU200 on the rack. Select EtherCAT in the Properties interface. Then tick Use EtherCAT and click OK. After finishing, the EtherCAT bus will appear, and then under the device directory on the right, expand the EtherCAT slave, find the slave we are connected to, and then drag it directly to the EtherCAT bus. I have completed the configuration here. If there is no slave you connected here, we can import the EtherCAT XML file under the tool. And then select the XML file of the slave you connected to add it. After adding it, it will appear in the EtherCAT slave directory, and then drag it to the EtherCAT bus. After completion, we need to configure the PDO parameters of the slave. Double-click the configured slave, set the interface parameters according to the actual situation, and then tick Expert Settings. In the Expert Process Data Setting interface, we have a set of input PDO and a set of output PDO. Below these two sets of PDO, four sets of PDO parameters are covered, and parameters can be added to the PDO content in each set. The A4N servo drive currently connected has some necessary PDO parameters added to its default description file. If we need to add other parameters, such as selecting the set of parameters 1600, the parameters in the PDO content belong to the group 1600. In the PDO content, if you still need to add parameters, you can directly right-click to add the parameters you need. If you want to edit the parameters here, you can also edit or delete the parameters after entering. You can add some feedback parameters in the input PDO, and then the parameters configured in the PDO will be displayed in the low map after completion. Each parameter will be assigned a PLCV zone address. This address can be modified. Please note that we will add axes later. The axes will occupy these addresses, so these addresses cannot be used elsewhere in the program, so as not to affect the normal use of pluck-open access control and the like. In addition, you can also add some parameters that do not require periodic reading and writing in the startup. Parameters. Right-click in this place. You can add the parameters we need, such as I added the original mode and the original search speed and crawling speed. Parameters like these, that do not need to be rewritten, often only need to be initialized, and assigned parameters can be added to the startup parameters. On this interface, we configure the speed of return to the original. Its unit is pulse. Then the No23 return to the original mode is configured here, and the return to the original track is as shown in the picture. Click OK when done. After the slave is configured, we are going to configure the axis. Click the Axis Configuration wizard. Double-click on the communication axis to add a communication axis. I have already added it here. Then you can configure the parameters of the axis. You can see that the axis ID is 0. It will be applied to the pluck-open instruction to distinguish which axis is controlled by the axis number. Then the type of the axis here can be set to linear axis or rotary axis. Then on the dimensional conversion interface, you can configure the dimensional conversion parameters of the axis and map the pulse with the actual physical unit. The configuration here is that the screw moves 10 millimeters and the motor rotates one turn, corresponding to 130,1072 pulses. If there is a gear reducer, you can configure the reduction ratio through the middle line. Then you can choose the type of acceleration curve below. Then on the speed interface, You can set the maximum and minimum speed of the shaft operation, the start and stop speed, and the configuration of the maximum and minimum acceleration and deceleration speed. In the limit interface, you can enable the soft limit if necessary, if it is set. When running to the limit, the axis will stop according to the stop method we set. Finally, we can see that these parameters just configured in PDO will be used on the axis side. So if we want to use axis instructions, these vZone addresses cannot be used in the program. After the configuration is completed, just click Finish. Next, we need to call the plukopen instruction library in the program to write a program for uniaxial control. The program has been written here. Let's take a look directly. The library instructions are in the plukopen library below the motion control library. For single-axis motion control, our main words are the enable of the axis, relative and absolute positioning, and speed control, as well as jog and return to the original. The current program, which writes the axis of the enable command, read the axis state and absolute positioning as well as jog and return to the original command. Then we will use this program to demonstrate its implementation effect. Instructions-specific pin description can be found in the manual. Here is not a detailed introduction. Check the hardware configuration and program blocks, and then select Download. After running the PLC, if the communication is successful on the hardware configuration side, we can see that a green checkmark will be displayed here. At the same time, on the LO mapping side, you can also monitor the current value of PDO parameters, such as operation mode and control words. It is currently enabled. We can monitor the program here. You can see that the axis is now fully enabled and in a standstill state. Now we can give it an absolute position and make it perform absolute positioning motion. Set the parameters of position and speed for it. After triggering the command, you can see that it is already in a straight line motion, and then it will move to the given position according to the speed we set. After the run is complete, we can see that it is back to standing still. At this time, we can use the original command to make it return to the original. We start back to the original through M0.3 in the state table. And then we can look and see what's going on here. After starting back to the original, you can see that it is now in the homing state, and then start to run in the direction of the positive limit at the search speed. If we give the origin switch rising edge signal at this time, it will slow down and reverse at the crawling speed until it encounters the origin switch falling edge signal to complete the return to the original, and it will be in the standstill state again. If you want to perform jog movement, you can set the speed for it here, such as triggering forward jog, and then it starts to run. The units of position and speed on the plukopen instruction library are application units, not impulses. On the I/O mapping side, the unit of the parameters we monitor is pulse, and the speed here is based on the dimensional conversion settings. The above is the content of the M260S's single-axis motion control through EtherCAT communication. Thank you for watching.